Let's get into segments and congruence. There are two types of problems that you absolutely need to know how to do. They're going to be on your test. Your teacher is going to go over them. What I want to do is highlight these three problems, work through them step by step, and show you some of the common mistakes that I see students make. So in this first example, we have use the figure below, PT. Thankfully, we have a drawing. And PT is equal to 5x plus 3, and TQ is equal to 7x minus 9. Find the value of PT. So the main important thing, ladies and gentlemen, that we have is these two little tick marks. These are very important because what these do is these show us congruence. They are saying that PT is going to be congruent to TQ. They are going to have the same length. Now that's very important because obviously if I said like that was 2, then we know that would be 2. Or if I said this is 5 and we say, well, what does X? We now can say, well, X is equal to 5, right? The length of the statements are going to be equal to each other. And guess what? We have the length of a statement for PT. We have the length of a statement for TQ. They're just an algebraic expression. So simply what we're going to do is just write out 5x plus 3 is equal to TQ is going to be a 7x minus 9. Now I'm using an equation because we know that those values are going to be equal to each other. And now we can go ahead and solve for X. Congruence in this context is really just saying that their lengths are going to be equal to each other. But when we get into solving, we're not going to use congruence. We want to use the equal sign because we know their measures are going to be equal. The last thing I want to highlight here is the question is saying, find the value of PT. A lot of students misread problems and they just go ahead and answer because now they see this is an algebraic equation and they get excited. They're like, oh yeah, I can do this, algebra 1. And they just kind of go through the steps and then put their answer and they forget. We're trying to find the value of PT. Now again, to find the value of PT, we need to know exactly what X is. Now here we have an equation though that we can solve for X. Now a common mistake that students will make is they know that they need to get the variable to the same side. Sometimes they'll put the X's on the left-hand side because they always like solving for X on the left-hand side. I recommend always solving for X when it's going to be positive, unless you just can't avoid it. But in this case, what I'm going to do is I'm going to subtract a 5X to both sides. We always want to get the X's over to the same side first. Now what I have is a two-step equation. 3 is equal to a 2X minus 9. Now I can use my inverse operations to undo what's happening to my X, so therefore I can isolate it. So I'm always going to undo addition and subtraction first. That's going to give me a 12 is equal to 2x. Now I can go ahead and divide by a 2 on both sides. And now I get a 6 is equal to x, which I can simply just reverse around and say x is equal to 6. Now again, I mentioned it at the beginning. Guys, this isn't our final answer. The question did not say find x. Right? That's what algebra commonly does. And yeah, some geometry questions will ask the same thing, but in this example, they're not. They're saying find the value of PT. So what do we know about PT? Well, PT has the expression a 5x plus 3. So if I want to be able to find what the value of PT is, and I know what x, the value of x is, I'm simply just going to replace my x with a 6 and then go ahead and add 3. So 5 times 3 or 5 times 6 is going to be 30, plus 3 is going to be a 33. And there you go. Now the next types of problem, whoa, that was fast. The next type of problem is, again, going to be kind of very similar. But in this case, it says S is between R and T. Now, again, a lot of students sometimes will mistake this. They see in between and they immediately think midpoint, and they maybe might even start forgetting about what they're trying to do. And they immediately just start doing exactly what we did in the last example. They set 2x plus 10 is equal to a x minus 4. And we do not want you to do that. Okay. Read the question. All right. It just says between. It does not say it's the midpoint. So be very careful. S is between R and T, even though the diagram looks like it's in between, it looks like it's perfect, right? But again, don't believe everything you see. Use the given information to write an equation in terms of X. All right, so we're going to write an equation, which we kind of know. We're going to solve the equation. Then we're going to find RS and ST. Now, here's the important thing. They give us RS. They give us ST. They're different expressions, right? But then they also say that RT is equal to 21. So this is going to be using what we call the segment addition postulate. And again, it just kind of makes a sense of like if I said this was 6 and this was 4, and I say, what's the length from R to T? Then we'd say that's 10, right? Because 6 plus 4 is equal to 10, okay? Now in this case, they're saying RS is 2x plus 10. We don't know what x is. And they're saying ST is an x minus 4. But using this understanding of the segment addition postulate, we know that RS plus ST is equal to RT. right? The two parts are going to add to give you the whole. Part plus part equals whole. Part plus part equals whole. Okay? So again, do we know what RS is? Yeah, it's an expression. We don't have a value for it, but we can say that's going to be 2x plus 10. I'll put it in parentheses so you can kind of like diagram. All right, that's RS. And then we have ST, which is going to be a x minus 4. Group those together. And again, that's going to equal to our whole, which is RT, which they say right here is going to be a 21. Now, all we have is, again, a multi-step equation. We have variables on the same side, though. So now we can just go ahead and combine our like terms. 2x plus x, or you can rearrange them if you want to. You can kind of drop the parentheses and just kind of do this, 2x plus x, and then plus a 10 minus 4. Sometimes that's a little bit easier if you're kind of struggling with the algebra. So 2x plus x, 2 apples plus 1 apple, is going to be a 3 apples. 10 minus 4 is going to be a positive 6. And then equals 21. Now again, we have our two-step equation. Use your inverse operations to solve for x. Negative 6, negative 6. 3x is equal to a 15. Divide by 3, x is equal to a 5. Now I didn't highlight it like I did in the last example, but again, we got x equals 5, right? I'm not going to walk away and just end the video. I want to go back and read the question. Solve the equation. Find RS and ST, okay? X is not RS and ST. We need to find the values of those two. So we can say that RS is equal to a 2x plus 10. So if I want to find the value, I'm going to plug in my 5 plus 10. All right, and that is going to equal 22 times 5 is 10. 10 plus 10 is going to be a 20. Then let's go ahead and get into ST. ST is equal to the expression of x minus 4. If we plug a 5 in for the x, we get 5, put it in parentheses, minus 4, which is equal to 1. Now, ladies and gentlemen, these are some very basic problems that you need to know. We all know that your teachers love to put on problems that they've never taught before and put those on your test and your quizzes. The way you need to combat that is you need to practice challenging problems. That's exactly what I'm going to go over in the next video. But if you're not ready for those and you just want some more practice on exactly what I went over in this video, I created a free worksheet down below that you can go ahead and download. Whatever you choose, get started now. I'll see you in the next video. Cheers.